Today's lesson, heat of neutralization and its constancy. Heat of neutralization that involves acids and bases. Heat of neutralization involves acids and bases, and constant value of heat of neutralization that involves strong acids and strong bases. That is to say, today I am going to discuss heat of neutralization and its constancy for strong acids and strong bases. So let's get started. Heat of neutralization for strong acid and strong base. For example, strong acid, hydrochloric acid, and strong base, sodium hydroxide. When strong acid is treated with strong base, then salt is formed, and in this reaction, 2 hydrogen atoms, 1 oxygen atom. So 1 mole water is formed. In this reaction, 1 mole water is formed. At the same time, this reaction generates around 57.34 kilojoule heat. What is the source of this heat? Let us have a look. Actually, this acid ionizes 100% to form proton and chloride ion, and sodium hydroxide ionizes 100% to form sodium ion and hydroxide ion. These compounds ionize 100% because these compounds are strong acid and strong base. Then chloride ion and sodium ion form sodium chloride that ionizes to sodium ion and chloride ion. That is, sodium chloride remains as ions, sodium ion and chloride ion, and this proton and this hydroxide ion form water. 1 mole water is formed. In this reaction, we see that chloride ion and sodium ion remain same before the reaction and after the reaction. That is why these ions are called spectator ions. Spectator ions, the ions that remain before and after the chemical reaction same, those ions are called spectator ions. Here we are going to see that what is the source of this reaction. In this reaction, living spectator ions are the ions proton and hydroxide ion combine with each other to form water. Here we see that combination reaction occurs. Combination reaction is heat producing reaction, exothermic reaction. Because of this reaction, this amount of heat is produced, which is called heat of neutralization. In this reaction, 1 mole water is formed and the reaction is carried out at room temperature, 25 degrees Celsius temperature. Now let us see what is the definition of heat of neutralization. Heat of neutralization is defined as the amount of heat generated by the reaction between acid and base at room temperature to form 1 mole water is known as a heat of neutralization. Simply the amount of heat which is produced by the reaction of acid and base at room temperature to form 1 mole water is known as the heat of neutralization. And we learned that what is the source of heat of neutralization? The reaction of proton and hydroxide ion. Combination reaction of proton and hydroxide ion is the source of heat of neutralization. That is, here only this reaction occurs. Because of this reaction, this amount of heat is produced and it's a kind of exothermic reaction. Now let us see whether this value is constant for another acid and base. In this reaction, basically this reaction occurs. One mole water. Because of this reaction, this amount of heat is produced, 57.34 kilojoule. Now let us see a reaction between nitric acid and another base, suppose potassium hydroxide. Here potassium hydroxide reacts with nitric acid to form salt, potassium chloride and water. In this reaction, 2 hydrogen atoms, 1 oxygen atom. So in this case as well, 1 mole water is formed, and in this reaction amount of heat produced is same, that is minus 57.34 kilojoule. Why this is same? Let us see the matter. This is a strong acid. It ionizes 100%. Proton and nitrate ion. It's a kind of a strong base. It ionizes 100% to form potassium ion and hydroxide ion. Here this salt is formed, potassium chloride, that remains as ions, potassium ion and chloride ion. Here water. In this reaction, nitrate ion and potassium ion. Nitrate ion, this is potassium nitrate. Salt is potassium nitrate. Potassium ion and nitrate ion. Nitrate ion, potassium ion. These ions are spectrate ions and only this reaction occurs. Proton and hydroxide ion to form water, which is 1 mole water. Like the previous reaction, In this case as well, same reaction occurs. Because of occurring same reaction, same amount of heat is produced, minus 57.34 kilojoule. Since same reaction occurs for different acids and bases, heat of neutralization is same. This is constancy of heat of neutralization. Let us see another reaction. Now, strong acid is, suppose, sulfuric acid, and strong base is, suppose, sodium hydroxide. This reaction forms salt sodium sulfate and water. Let us balance the reaction. Here 2 sodium ions, so here 2, then 2 hydroxide ions, 2 hydrogen atoms. So actually 2 moles water is formed here. In this reaction of sulfuric acid and sodium hydroxide, that is 1 mole sulfuric acid is treated with 2 moles sodium hydroxide, then 2 moles water is formed, 2 moles, and in this reaction amount of heat produced is approximately minus 114.68 kilojoule. In this reaction, this amount of heat is generated. Now let us try to see constancy of heat of neutralization. Here, it ionizes fully to form 2 hydrogen ions, sulfate ion. It ionizes fully to form 2 sodium ions and 2 hydroxide ions. Here, salt is sodium sulfate that ionizes 100% to form 2 sodium ions, sulfate ion, and 2 moles water. In this reaction, sulfate ion, sodium ion, sodium ion, sulfate ion. These ions remain unchanged before and after the chemical reaction. That is why these ions are known as spectator ions. Now, 2 protons, 2 moles protons combine with 2 moles hydroxide ions, and as a result 2 moles water is formed. Here 2 moles water, and this reaction generates 114.68 kilojoule heat. That is here. If we divide this reaction by 2, then we get proton, hydroxide ion, here 1 mole water, then amount of heat produced will be minus 57.34 kilojoule. That is, we learnt from the definition of heat of neutralization. Heat of neutralization is defined as the amount of heat that is produced from reaction between acid and base to form 1 mole of water at room temperature. So, in this reaction as well, to form 1 mole water, this amount of heat is produced. That is constancy of heat of neutralization. Constant value of heat of neutralization for strong acids and strong bases that remain constant for strong acids and strong bases. No more today. Thank you very much.